We're going to take a break from the SAT questions and go over UIL mathematics questions, specifically how to save some time on the questions using TI-Nspire coding. Now, we're going to need to know the volume of a cone, given the height using this formula, and also the surface area of a cone. Here's the formula itself. But for sure, make sure you know how to use these by hand before jumping into the coding, please. Now, let's take a look at this question. It says the volume of a cone is 2,430 and the height is 13. What is the surface area? Well, the surface area formula relies on the radius and the height. Here, we do know that the height is 13, but we don't know the radius, so that's our goal. So we're going to use this information to help us figure that out. Now, to find the volume of a cone, here it is. We're going to say that 2,430 is equal to 1/3 times pi times radius squared times the height, which is 13. If we do a little bit of algebra here, we can even use the calculator. We'll get 13.3603 is our radius. Now we can jump into this formula to find the surface area. So the surface area will be equal to pi times 13.3603 squared plus pi times 13.3603 times the square root of 13 squared plus 13.63603 squared. And whenever we end up plugging this into the calculator, we get 1,343.2. Now, in order for us to make this go a lot quicker, we need to find a method, and the method is to use TI-Nspire coding, which is what we're going to cover next. So what we're going to do first is go to New, and then we're going to go to Program Editor, click New, and then we're going to type in vcone h and select Function, and go to libhub. Click OK, and then we're going to type in r, h, which is going to be what it's going to be feeding into the program itself. We'll type in local v so that we know what variable we're using, and then we're going to type in the formula to find the volume of a cone. So we're going to get 1/3 pi r squared h, and then we're going to store that by doing second bar into v. We're going to return v, then we're going to do menu to 1 to store it, and then menu to 3 so we can test it, so we can run it. And we do 310, and we get a volume of 94.2. Next, we're going to go to second doc, and we're going to do another program called SA cone h, and we're going to go to function, and then we're going to go to libhub again, and this one we're going to create the formula how to find the surface area of cone by doing r, h, which is what we're going to feed it, do the variable of SA, and then we're going to type in the formula to find the surface area of a cone in this one. Now, I made a couple of errors here, but when you come down, just make sure you come down from the power, and it's going to be pi r squared h times pi plus pi r, and then the square root. Make sure you put the multiplication, because sometimes it gets a little finicky. So square root of h squared plus r squared, and then we're going to store that into SA, the variable SA, and then we're going to do return SA, and then we're going to go ahead and store it and making sure that the syntax works. So it's going to be menu to 1 and then menu to 3. We're going to test it to see if it works out. We're going to do 3 and 10, and the 3 represents the radius, the 10 represents the height. Here we're going to go ahead and solve the question that we just finished doing. So we're going to do nsolve. We're going to go ahead and try to find the radius by typing in the program that we wrote for the volume of a cone by doing r, 13 equals to, and the 2,430, r. And then here when we get it, we got the radius. Now we're going to use the surface area formula, and we're going to go ahead and just type in the radius first, and then we're going to go ahead and type in the height itself, which is 13, and you can see it's a lot quicker this way.